All right, let's get started. It's 10:05. Thank you everyone for joining. Today we have Mark Hutner with us, and he is going to deliver our third LinkedIn Live, and he'll be talking today about new approaches for managing complexity in IP debug. So I'm going to pass it over to Mark now.
Thanks, Kaylee. So as Kaylee mentioned, I'm going to be talking about IP debug and how you do this on an ATE system. I'm a senior systems engineer and part of the advanced R&D team at Teradyne, looking at these futuristic kinds of topics, but this one's actually very close to how people work today. So if you look at how people design chips, and this is really a design chip discussion, basically, the problem today is the amount of time that it takes to design a chip has been increasing. So if you look about 5 years ago, it was 100 staff years, and it's quickly gone up to about 500 staff years or more. So how do you do this efficiently is really what it comes down to. And what started happening a while back was that the IP market, starting with like processor IP, and now with all sorts of kinds of IP, and I've got a list over on the side here in terms of like analog blocks, interfaces like DDR controllers, or even 112 gig PAM4. Those kinds of blocks people are buying from other people to accelerate the time it takes to design a chip. So this market has been growing significantly and is now sitting around a $3.9 billion market. And that includes all kinds of IP, not just interface IP, but processor IP or digital libraries. So, and this is growing quite significantly. Now, you don't have to just take my word for it. There's an article that just came out last week where they were talking about the interface IP market, and that's actually growing at closer to a 40% per year going forward. So this is going to be a very exciting point because there's a lot of new interfaces that are coming out, and those all will have debug challenges at ATE. So at the ATE side, usually when I talk about DFT, people immediately go to scan. So I'm going to get upfront and talk to you about that immediately. You know, there's really two kinds of blocks that we have to consider. One is digital and standard cell and using scan. And really, there's a reason why it's easy and a reason why it's hard. And when you're using the same process technology, the same digital library, and the same tool flow, it usually comes up within hours or days. But even there's some bring up problems. So, you know, if you are in a new process, use a new digital library, have a new tool flow, that could take weeks. Now, since I'm not going to talk about it today, I do have to point out that we do have some optimized workflows, some DOE infrastructure, so design of experiments, like a really good characterization environment, as well as ways to capture the scan diagnostics for each of the major EDA vendors. So if you're interested in that, I would suggest that you go talk to your AE from Teradyne, and you can go learn about those approaches. Now with hard IP blocks, it sort of has the same fundamentals. So if you're reusing the same blocks, which is process, IP vendor, analog circuit, tool flow, it can be as easy as 2 days. Now, where this gets difficult is really where you have a new revolutionary architecture, a new process technology, a new IP vendor or analog circuit and tool flow. So there, it could be as bad as a month or 2 months or 3 months. So the premise here is that there's a better way to do this rather than how we're doing it today, which is really approach each block as a separate entity. So what we've developed is a common approach to help you get that down to days instead of weeks, months. So why is this hard? It shouldn't be hard. We've all been doing this for a while, but why is it hard? And ultimately, there's really still two silos. There's the design silo on the left, and they speak certain languages. You know, it's 1149, which is JTAG, IJTAG, which is 1687, 1500. It could be software. And then the test engineers speak a totally different language. It's patterns and vectors and bits and test instances. So this is really difficult. When there's debug occurring, how do these two people communicate? and work together. And it really starts with a language gap and an approach gap about how things are described. And then there's a time to market cycle time problem of this guy on the right might be in one area of the world, and this guy on the left, or this woman on the left, might be in another area of the world. So you might only get 1 or 2 tries a day to debug something in some scenarios, but it's really, how do I do this and get the debug down to a short amount of time as possible, because I want to start shipping my product. Now, there's been a lot of developments, and I was part of a special session at VTS this year, a couple months ago, and in it there was this slide which talks about the history of standards. We were talking about how to accelerate chiplet-based tests, but it's a good summary of all the various standards. So we started a while back with boundary scan and then core wrapping. So basically it was, how do I test around the chip with IP? That extended to the actual IP blocks. Then people started to add hierarchy with core wrapping, and this is IEEE 1500. That then moved to an abstract view of retargeting with 1687 about 5 years ago. And here it became extremely difficult for a test engineer to look at a vector and know which area of the chip it was targeting. So if you look at this block diagram, there's a block that says SAR. There's a couple of them. And what those are muxes, which you can start skipping sections of the chip. So when you look at the actual vectors, it became very difficult to know where you are. Now, last year, or thereabouts, there was a new standard introduced for 3D IC, which starts to talk about how do I go through the stacks of the chips. So this will add another layer of complexity. And what it's really talking to is, I really need a tool to understand the tests, and I really need an abstract language. So what we did at Teradyne was tried to connect these two worlds so the people can collaborate better. So it's really, I have a debug problem from the design side, and the test engineer is seeing a fault. And how do we address that language gap I talked about previously? And how do we address that cycle time problem? So what we've done is connect up the design tools to the tester. So there's some setup that one does on the tester side over here, which creates a set of test instances. And then you basically enable a network port, so that way you can connect up design tools through a secure system. So then all it becomes is really, I'm ready to debug. I see a problem at the part, and the design guy can go link in with their tools. And the example here is more of the Tessent tools from Mentor, but we're not limiting to that in the future. So why do we need to do this? We need to do this because we need to enable collaboration, because that cycle time is very important. But in the system that we created, it's really hardware and software platform independent. So we tried to build a piece of software where we can leverage it in lots of different areas. So on UltraFlex and UltraFlex Plus, it works on both platforms, and it's actually transparent. Now we have a standard set of protocol libraries. We're minimizing program complexity. So this is actually going to make your test program simpler in the longer term, which is very exciting. And there's some other tools that Teradyne offers that help enable that as well. There's connections to external tools, and I'm going to talk about one in a second. And going forward, there's some new standards. So we're going to end up controlling some ATE resources. So clearly, this is a better way. Now, where does this help? Now, the big place where it helps is interfaces and complex IP blocks or cascaded IP blocks. So it could be something like memory bits, it could be SerDes, it could be mixed signal IP, or cascaded blocks. So there's lots of opportunities here that we could explore. And it depends on where your debug problem is. Now, I will be giving a webinar jointly with Mentor in a couple weeks. It's on July 28th. Where we're going to talk about a couple of use cases. So I'm welcoming you to join us then as well. We'll discuss things like memory BIST. It will be, it's very helpful, and we can go further on a one-to-one basis if you'd like. So really what it comes down to is, we really need to work together. What we can improve is time to market. There's a potential of improving quality and test coverage, but we really have to understand where your challenges are. And so we have to start with, what are your bring up challenges? What is your design flow and how we can best meet that? And what's your TTM goal? So how much of an improvement you have to do to really get there. So we're here to support you and help with all of your debug efforts. So I'd like to thank you for your attention, and I look forward to hearing more from you.
Okay, great. Thanks, Mark. If anyone has any questions, feel free to type it into the Q&A panel on the side of the LinkedIn Live. And if not, as Mark said too, feel free to reach out to him on a one-on-one basis, and I'm sure he'd be able to answer any questions that you have. And just so everyone knows, this session will be recorded and available on Teradyne's LinkedIn and our AI webpage, teradyne.com/AI, following the session. All right. I don't see any questions, so I think that concludes today's session, and we hope you join us next time. Thank you.